Welcome to the lecture in Introduction in MATLAB, the course TSRT04 at Linköping University, and I'm Emil Björnson. In this video, I will provide you with the MATLAB basics, vectors and matrices, talk about built-in functions, and then the difference between scripts and functions, visualization, control structures, and then I will summarize. So let's start with MATLAB, what it is. MATLAB stands for Matrix Laboratory, which tells you that it was created for linear algebra, working with matrices. And today, it's an advanced calculator for technical computing. So it's a bit like a pocket calculator, but with a much more powerful things underneath. And it also contains a simple but powerful programming language. And this is a program that performs numerical calculations, which means that you calculate something and you get a number as the result. There are other programs like Mathematica or Maple that can provide you with a mathematical expression, an equation as the answer to something, but that's not what you use MATLAB for primarily. And MATLAB is a program that is available for Windows, Mac and Linux, and you can also run it in your browser. And there's usually new versions twice per year. For example, 2019A, 2019B, 2020A, and so on. However, when you do this course, it's not so important that you have the latest version because we will not cover those things that are updated in every version. The good thing with MATLAB is that it's easy to get started and it's very easy to visualize results. So you might be using MATLAB to provide you with nice plots for lab reports in all kinds of courses. And there's also many examples and toolboxes for various topics. So MathWorks, who is doing this program, they are selling this to a number of different companies so that they can build things based on math, statistics, optimization, telecom, control, biology, finance. Those things goes into this program. And also machine learning, deep learning are things that are pushed in MATLAB the latest years. The con might be that it's not the fastest way to code. If you really want to do something that should be used in a product, you typically are not programming it in MATLAB. But nowadays it's usually fast enough for everything that you would like to do. So I think it's very suitable to use MATLAB for testing ideas, solving scientific problems, developing or validating algorithms. MATLAB is a proprietary program built by MathWorks, but there is an open source option called the GNU Octave, and it's made to be MATLAB compatible. I'm working a lot with MATLAB every day, so my research is in the area of 5G wireless communication. We try to develop design principle for the next generation cellular networks. For example, trying to understand the interplay between the data rate that your wireless network can deliver per user, which you measure in bits per second per user, or the data rate that everyone in the area is sharing, the area data rates in bits per second per square kilometer. And another important factor is the energy efficiency, which is measured in bit per joule. And this graph here is something that I've generated in MATLAB, which tells me how these three different factors, energy efficiency vertically, average area rate, and average use rate, how they can interplay with each other. So there are different points here that are achievable in different ways. And in my research, the role of MATLAB is to test models, develop algorithms, visualize trade-offs as you see here, and then if you really want to use this in practice, you are going to re-implement things in a different way. So let's look at the MATLAB interface. What you see here is how MATLAB looks like on the Mac. You have down here something called a command window. This is where different commands that you're writing will appear. And if you would like to write command, you have the command window here where you write them in, and when you write something, it will appear in your command history. Then there is something called the workspace. Here is name of variables and their values. So things we are storing is going to be showing up there. Let's start with using MATLAB as a pocket calculator. In that case, we use the command window as you would do with the scientific pocket calculator. So you can type in numbers like 30, or if you would like to use the number for pi, you just write pi. And if you would like to write 1 times 10 to the power of 2, which is 100, then you write 1e2. In that way you don't need to write very long numbers with a lot of zeros if you want to write something like a million or so. Conventional operators like plus, minus, divided by, or multiplications are just written with those typical type of characters. And the cosine, for example, is written with cos, the sine with the sine. A lot of functions already exist within MATLAB. The absolute value, for example, is written by abs. So to a large extent, you need to learn the names of different functions that are used in MATLAB so you can calculate things basically. So let's make an example here. Say that we write 2e3 plus 300. Then we press enter and we get the answer 2300. That's because 2e3 means 2 times 1000 or 10 to the power 3 plus 300. We added them up and we get this result. And you can see now in the workspace the answer is 2300. Then we can use a built-in function like cosine. And let's compute cosine of pi. In this case, it answers with -1. And now it says answer -1 in the workspace. And let's also use abs, which is the absolute value. And the absolute value of 1 plus 1i, 1 times the imaginary number. If you remember how that works, we take the real part 1 to the power 2 plus the imaginary part 1 to the power 2, add them up, that's 2, and then we take the square root. And you see that MATLAB is not answering with the square root, but with the number here. And actually, even if it presents only 5 numbers here, it is storing many more numbers than this. It just refuses to present them unless you tell MATLAB to do it. What is a variable? That's a container that you can save values in. It has a name and it has a value. If you write a equal to 5, then you create a variable with a name a and the value 5. So let's try that out. A is equal to 5. Now you can see here in the workspace that you have a variable with the name a and the value 5. We can now use this variable for other things. Say that we would like to create a new variable, b, which is equal to a plus 3. In that case, when you press enter, MATLAB is going to take the value that a has, which is 5, replace a with it. 5 plus 3, that's 8. You press enter. It says b is equal to 8, and in the workspace you now have b equal to 8. Let's now say that we write a is equal to a plus 2. What is going to happen? Well, a on the right hand side has the value 5. That is what is written in the workspace. And MATLAB is first starting with everything that happens on the right hand side of the equality sign. So it takes value 5, put them in here. 5 plus 2, that's 7. When you press enter, a is equal to 7. And you see that the workspace now has been updated. A is 7. Importantly, b is still equal to 8. So even if we created b by using the value of a, we only store a number 8 in the variable b. So it has no memory of how it was created. So the workspace is containing all the variables that you're using, and you can view it as a file cabinet where things are getting stored. And if you give variables a name, well then they appear in that name. If you just make a calculation, sort of like abs 1 plus 1i, as we did earlier, it responded with ans equal to something. And then it actually creates a variable called ans for answer. And that means that even if you don't provide a variable name, it's going to create the variable for you with that name ans and the number. But you should never store anything important in the variable ans, because that is something that gets overwritten all the time. And you can double click on one of the variables and then it's open up a spreadsheet here where you can see that, okay, it is a 1 by 1 variable with a number 7 in it. And if you like to be knowing more about the variables, you can also write the command whos, and then you can see, okay, these are the 3 variables we're having. There are names, there are sizes, the number of bytes, and what data type they have been stored with. And in general, in MATLAB, you never need to think about what data type is being used. MATLAB is created from the beginning to deal with vectors and matrices. And that means that we could type them into MATLAB in a very simple way. So say that we would like to create a vector, which is a row. A is equal to 4, 5, 6. Well, then you type that into MATLAB by writing A equal to, and then you have these brackets, 4, 5, and 6. And if you want to, you could have a comma between them. The important thing is that there is a blank space. When you write that in to MATLAB, it's going to create a variable for you. So A is 4, 5, and 6. And now we can see we had the variable A. It contains the values 4, 5, 6. If you double click on it, you open up this spreadsheet and you can see that it has filled in several numbers now. Say that we instead would like to create a column vector B with 1, 2, and 3 in it. Then you write B is equal to 1, semicolon, 2, semicolon, 3. So B is equal to 1, semicolon, 2, semicolon, 3. And if you double click on B, we see 1, 2, 3 is inside of it. Now suppose we would like to create a matrix. A is equal to 1, 2 on the first row, 3, 4 on the second row. Then we should remember what we were doing. Whenever you put two numbers in the same row, we write them after each other, and then we have a blank space in between. And when we would like to create a new row, we use a semicolon. So 1, 2, you write it 1 blank space 2, then a semicolon to start a new row, 3, and then blank space and 4. So capital A is 1, 2, 3, and 4. And if you double click on it in the workspace, we see 1, 2, 3, 4. So that's a way of creating vectors and matrices. And if you get disturbed by that every time you write add that A is equal to 4, 5, 6, MATLAB is responding, as you can see here, A is equal to 4, 5, 6, you can silence MATLAB by ending a line with the semicolon. So a simple way now, we could take the command history, we could drag the command A is equal to 4, 5, 6, and now we end with the semicolon. And then we get just a new row without typing out again what A is equal to. If you would like to create a matrix transpose, you write a dot and then this type of apostrophe. So if A was 4, 5, 6, A dot apostrophe is now a column vector 4, 5, 6 instead. And there are some special matrices and vectors that are very commonly used. For example, if you write C is equal to I2, you get 1 on the diagonals and zeros on the off diagonals. And the 2 here said that it's going to be a 2 by 2 matrix. If you write instead C is equal to I5, you get a 5 by 5 identity matrix. 1's on the main diagonals and zeros elsewhere. And if you would like to create such a big matrix, which is an identity matrix, it's much better to use this command directly. And if you would like to type in all numbers between 3 and 6, which are integers, you don't need to write 3, 4, 5, 6. You just write 3, 6, and MATLAB understands that you want to have 3, 4, 5, and 6. And if you would like to skip over some numbers or have more numbers in between, you can write something like this. Y is equal to 2, 3, 11. In this case, 2 will be the first number. Then we add 3 to it and get 5. Then we add another 3 and get 8, another 3 and get 11. So we can type that. 2, 3, 11. Then y becomes equal to 2, 5, 8, 11. If you would instead write 12, you still get 2, 5, 8, 11. If you end by writing 13, you also get 2, 5, 8, 11. And if you write 14, you get 14 as the last number. So what it really is doing, it's take 2, then add 3, then add another 3, and it continues until it gets a number that is above the last number that you're providing. And then it stops. So you don't need to know exactly where to stop. And this is also very convenient if you would like to have all integers between 1 and 100. Well, then you just write 1 to 100 and you get all those numbers directly. MATLAB is created originally to deal with matrices, so we can do a lot of matrix operations very easily. So if we create a matrix A, which contains 1, 2 in the first row and 3, 4 in the second row, and we create the matrix B, which is an identity matrix of size 2, if you then just write A times B, MATLAB is going to carry out standard matrix multiplication, which results in 1, 2, 3, 4. So this is a matrix multiplication. For example, the first element here, 1, is created by taking the first row in the first matrix, 1, 2, multiplied with the first column in the second matrix. So 1 by 1 plus 2 by 0. And that gives us the 1. There can, however, be cases where you instead would like to multiply elements element-wise. So if you write A dot multiplied with B, then you will get instead 1, 0, 0, 4. And that is what happens when you take the first element in both matrices, multiply them together, the second element in both matrices, multiply them together, and then you continue like that. And similarly, you can take a matrix to the power of 2, that means that you multiply the matrix with itself, or dot to the power of 2, then you take each element in the matrix and take that one, multiply with itself. You can divide a matrix with another matrix. What really happens then is that you multiply with inverse. And with dot divide, well, then you are dividing the elements element-wise between the two matrices. There are a lot of built-in functions in MATLAB. For example, you have basic mathematical functions like x, that is e to the power of something, log, which is the natural logarithm of something, the sine, the cosine, and the tangent. And in all of these cases, you put the vector or matrix into them, and the output of the function is going to be to compute that function of each element, one by one. Then there is things that I call ordering function that takes an entire vector, and then it do some processing of the elements together. So the min is the minimum of the vector, max is the maximum, mean, that is the average value, and sort can sort them in ascending or descending order. Some functions work element-wise. In those cases, you create here x is equal to 0, and then you go pi over 2 up to 2 pi. So then you get these numbers. 0, this is pi over 2, pi, 3 pi over 2, and 2 pi. If you then put those numbers into the sine functions, what you are going to get is that you compute the sine for different values. The sine of 0 is 0. The sine of pi over 2 is 1. Pi is 0. 3 pi over 2 is minus 1, and 2 pi is minus 0. The reason that you see 1.000 here is that MATLAB have a limited accuracy in its computations. So it doesn't know that this number here is pi over 2. It just computes something that is based on an approximation of that number. And then you have maybe 16 digits accuracy, but still in the end there is some inaccurate thing here that makes it not answer with just a pure 1. Then, as I said, there are some functions that process all elements at once. So say that you compute the maximum of x, then it will look at all the elements in x and take out the maximum one, which is 6.28, and that's what you're going to respond with. The next topic is matrix indexing. So how do you access specific elements in a vector matrix? Well, say that you have this vector y with 0, 1, 0, minus 1, 0. If you write y of 4, then you are going to get one of these numbers. Which one? Well, it's important to know how you index things in MATLAB. In a lot of programming languages, we are starting indexing from 0, but that's not the case in MATLAB. You start from 1. So this is the first element, second, third, and fourth. So if you write y of 4, you get minus 1 as the answer. If you have a matrix, 3, 5, 2 on the first row, 7, 8, 6 on the second row. If you write A of 1, 2, we need to know how you are computing things in a matrix. Is it first the rows that you're specifying or first the columns? Well, the answer is that it's first the row. So that's always the case for matrices. So first row, and the 2 here says second column. So it's the 5 here that you're going to pull out. There are many more functions built in MATLAB than those I have exemplified, and therefore it can be good to search for functions whenever you're looking for something. Say for example that you would like to look for something that computes a determinant of a matrix. In this case you can write look for determinant. So let's try that out. Look for determinant. And when you press enter, what MATLAB is going to look for is the term determinant in its documentations. And it presents you with a lot of different options here. And all of them are computing determinants in different ways. And the last one here, det, that is the pure determinant calculations. How do you learn how det works? Well, you can either click here or you can write help det. And then MATLAB is going to present you with an information. Det is the determinant. Det of x is the determinant of a square matrix X. And then it talks about some other important informations or other related functions. And if you don't think this is enough, you can write doc det to go into the documentation, and you can also click here on the reference page for that. That's the same thing. In that case, a special window is going to open up and provide you with a lot of information about the determinant. So with different examples, live scripts, so you can try them out. So there's always a lot of information inside MATLAB that can be used. So how do you know how a function works? Well, you write help of the name of the command, and then you write doc and the name of the command to get more thorough information. And in general, you can just write doc to open up the entire MATLAB documentation, or help to get a list of the toolboxes. Let's now go beyond the pocket calculator and talk about scripts. This is a way to perform many commands at once. So instead of typing in every one of them in this command window, this is a much better way of doing it, typing them into a document. And this document is called a M file because it's a pure text document, but it ends with .m. In this way, you just provide MATLAB with different commands one after the other. And you can use any text editor, but I recommend you to use the MATLAB editor, which you can open by writing edit. And the reason for that is that it will provide you with some good help on color coding variables or telling you when something is not written in a correct way. And you can also write comments in your code. That's another good reason to have a script. You write a % sign and then you write a comment. And I strongly recommend you to always use scripts when you are programming something serious in MATLAB. In that way you can list all your commands one after the other. It's easy to reproduce your result and easy to write comments using this notation, and it's also easy to make small changes and rerun everything, and in that way making sure that you are making your computation the right way. So let me give you an example of how to create a script. Say that Lena has run 5 kilometers on the time 23 minutes and 15 seconds. She wants to compute the time per kilometer, and she wants to do the same thing next week. So that's why she would like to save how she did the computations in a convenient way. Here is the MATLAB editor, and I've created a file that I call computerunpace.m that can do these computations. So the first line here is distance is equal to 5. That's the distance in kilometer. I've written it with a comment, and you see it gets green marked by the MATLAB editor. Then I have minutes equal to 23, seconds equal to 15, and I write here is the total time expressed in minutes and seconds. Then let's do the computations of the time per kilometer. So first I compute the total number of minutes plus seconds divided by 60, and I store it in total minutes. Then I take total minutes and divide by distance, and we get the min per kilometer. To run my script, I click Run, go to the window, and now what we have written out here is the result, min per kilometer, 4.65. And the good way of writing script is that you can modify things. So say that Lina is now running 8 kilometers on 32 seconds and 19 seconds. In this case, you just make these changes, click Run, go to the MATLAB window, and now we have a new computation. And you can see that all of the computation that I made have been stored in the workspace here, so all the variables are available there. So that's an example of a script. What is the difference between the script and the function? Well, a script is just a collection of commands. You list all the MATLAB commands one after the other in a text file, and when you are running the script, it's going to use MATLAB's general workspace. So as we saw, all the variables were listed there. And there are good and bad things with that. You can, for example, overwrite previous variables if they have overlapping names, or you can unintendedly use previous variables, which is a coding error. If you use a variable in the script that you haven't created inside that script. There is an easy solution. You just write clear in the beginning of your script, and that empties the workspace. That takes care of these problems. However, there are good reasons to use something called functions instead. That is another concept because they have their own local workspace. So they work just like MATLAB's own built-in functions. And it's an excellent way of reusing the same code multiple times. So you write something that is used for a particular purpose, you test it well, you save it as a function, and then you don't need to touch it again in terms of what goes inside of it, but you can send different information into the function. Here is an example of how you can rewrite the compute run pace program into a function. Every function is also a .m file, and it starts with function. That tells MATLAB this is a function and not a script. Then you have the compute run pace here, which is the same name as the name of the file. You have dist min s here. These are things put in parentheses. They are input variables, so the user needs to provide those ones. And then you have min per kilometer and an equality sign. This means that the function will compute min per kilometer given dist, min, and s as inputs. And you have a comment here in the beginning, computes the time per kilometer in minutes given the distance and the total time expressed in minutes and seconds. In that way, the user knows what the inputs are. Here we compute the same things as before, and you can end the function with end if you like to. It's not mandatory. If you would like to use this function now, and you don't know what it's doing, you can write help compute run pace, and then the comment that we wrote right after the first line is going to be presented. If you write compute run pace and start to write input parameters, it shows here what you need to put in, dist, min, and s. If you remember now, she was running 5 kilometers at 23 minutes and 15 seconds. And if you are pressing enter, you get the same result as before. And it's easy to try out with other numbers here. You press enter and you get the new result. So let's now talk about how the function execution is taking place. So when you run compute run pace 5:23:15, then you have the workspace in MATLAB where variables are being stored. And right now it's empty. And when you start running the code, it will remain empty. Instead, we will get a new workspace for this particular function. And in this one, dist will be 5. That's coming from the input. Min will become 23. And s will be 15. And then the function is running and executes row by row. So total minutes getting computed. Then min per kilometer. And then you're reaching the end of the function. And at that time, the min per kilometer, which is the output, needs to be set. And now, this output is sent back to the compute run pace. And now the value 4.65 is sent back to MATLAB's general workspace, saved in this mpkm variable, and after that the workspace for this compute run pace disappears. And now you can't get any of those things back again. So this is how a function works when it executes. So you are putting all the computation that you like into a function. The input is the information you can send into it. The output is the information that you can take out of it. And the rest of it is just internal. A combination of scripts and functions is what you're going to use in MATLAB when you are programming yourself. Functions are created whenever you have an algorithm or some multi-row computation that you will use more than once. And you're testing it properly, make sure that it does what it should, and then you save it as an M file and you don't need to go in and touch it again. Scripts are defining input variables for the task that you're going to solve. Then you use them to call different functions, some of them being your own functions and some of them being the built-in MATLAB functions, which are written in the same way as the functions you do yourself. And then the output you're getting is something that might be processing in one way or another. You visualize the output from the functions in different ways, export something for your lab report and so, and then you are done. So if you would like to see how I work in MATLAB, you can go to my GitHub page and download my code from there. And that is also a good reason for using MATLAB, because you can publish code online, anyone can download it, run it directly in MATLAB, it's just going to work. So it's simple to reproduce things. So I was mentioning visualization as one of the important way of using MATLAB. Suppose you want to plot or visualize a mathematical function. So we have x that goes from 0 to 10. You would like to compute y, which is sine of x, and you would like to draw a graph of that. Well, let's create a script that they call plot sine for that purpose. What will go into this plot sine M file is that first I define values of x. We wanted to have values between 0 and 10, and we need to decide on which values. So I've written from 0 to 10, and then that we're going to get in small steps of 0.1. So I get 0, 0.1, 0.2, 0.3, and so on up to 10. And this is when it's very convenient to write like this, because otherwise you're going to get a lot of numbers to type in yourself. And then we, for every value of x, we compute the sine of it and store it in y. And now we can start plotting the results. And then we have these 5 lines here. The first one is figure. It opens a new figure, so that is a new window. Then you have a command to draw the figure that you want to have. Plot xy. That is drawing a line plot with x on the x-axis and y on the y-axis. Then you would like to put some information into the graph so you know what it contains. So let's write an x label. That is what goes underneath the horizontal axis. You will just say x. On the y-axis, we will write y is equal to sine of x. And then above the figure, we'll write my first plot. Let's run it. And here we have a figure. It's a window by itself where you can control a lot of different things. We see that x is written underneath. That's the x label. Here we have a y label. Here we have the curve that we have been drawing. And there's a lot of things that you can change when it comes to your different curves. We can change the line style, the line width. So if we would like to make it much thicker, we can do that. We could change the color. So let's say we will like this orange one. And we can change the style in terms of that it should be a dashed line, for example. And this is particularly important when you have more than one graph in the same plot like this. Then you will like them to be possible to separate in an easy way. And instead of making changes like this by yourself, you can actually go into MATLAB and write help plot, and then you get the information about how to change different things. For example, here are commands for choosing the color, choosing how to put up markers on your curves, and what type of curve. Is it solid, dotted, or dashed line that you're going to plot? One thing that's important to understand is that what we are plotting is actually not a line, but a collection of points where we put straight lines between them. So we know what sign of x is for these particular values of x. And if we change here from 0 to 10 with jumping just steps of 1, and we run it, then this is supposed to look like a sign, but you see that it doesn't really look like that. And the reason for that is that we only know the value here at 0, 1, 2, 3, 4, 5, and so on. And in between, MATLAB will just draw lines between them. So in order for it to look nice, we need to have a dense set of numbers. Now it looks like a sign, but if we are putting out markers, we can see that it's actually these points here where we had a number, and then in between them you just have straight lines. This is something to be careful with when you are creating your own plots. I was exemplifying creating a graph with a sign, which is a so-called line plot, but you can create a lot of other types of plots. 2D lines with the plot command, semilog x, which is creating a logarithmic scale. Then you can create bar diagrams with the bar or histogram commando. You can create 3D line graphs with plot3, or bar or mesh graphs in 3 dimensions with bar3 and mesh, and 3D surface graph with surf, sphere, ellipsoid. A lot of different commands like this. And whenever you are looking for something, you just find out the command by using the look for or the documentation, and then you can write help and the name of a command in order to figure out how it works. And if you would like to have more examples, you write doc and then the name of the function. The final part of this video is about control structures. And when you are programming, there's some behaviors that depend strongly on what kind of input you're having. For example, does your bank account have enough money or not? Well, that is important to know if you should, from an ATM, give out money or not. And there can also be some pieces of code that's going to be repeated multiple times. And in that case, it's important to know, if you know in advance, how many times you're going to be repeated, or if that depends on some kind of logical expressions. Well, in these cases, you will need if clauses, for and while loops. And these are the control structures that I will be talking about. And these things is something that you are familiar with from other programming languages, but MATLAB have its own syntax, so the important thing is how you are writing things in MATLAB. So an if clause have this general syntax. You write if and then a condition, and then you can write some statements or commands that should be run if this condition is true. And then you can write else and have some other commands that are going to be run if the original condition was false. And then you end with end. And this else can also be removed if you only would like to have something that happens if the conditions are true. The important thing is how you are writing conditions in MATLAB, and you use logics for that. Greater than, greater or equal, two things being equal. You can use this AND command to have two different logical things that needs to be true at the same time, or this one when one or the other or both are true, or not equal to, or smaller equal to. And to give you an example, say that you have savings, which is a variable that contains the amount of money on your bank account. And then you can write savings greater or equal to 0. Well, if that is true, then something might happen, such as you can withdraw money from your account. Alternatively, you can have two conditions: savings greater or equal to 0, or salary being greater than 35,000. That could be that, okay, if you don't have money on your account but you have a good salary, well, then maybe you can still hand out money to your customer. So here you see that this or here is saying that one or the other or both should be true. There is also a command called XOR that can be used to say that one or the other but not both should be true. So let me give you an example of how to use if clauses. Say that you have a bank account with 2% interest on savings and then it charges 14% interest on credits. Write a function that computes the interest for a given amount. Here we have a function for that purpose. It starts with function. It's called compute bank interest, and amount is what we are sending into it as input. And interest is what you're going to have as output. And compute annual interest for a given amount, that is a comment that describes what the function is doing. And here we have an if clause. If amount is greater than 0, then we should have 2% interest. So you take the amount, you multiply with 0.02, and then you get the interest number. Else, that happens when the amount of money is negative. Then you should have 14% interest rate. So you take your amount, multiply it with 0.14, and you save it as interest. And then you leave the if clause, you reach the end of the function, and interest is what you're going to send back. So let's now try out this function. You write compute bank interest, and as input we take 1,000. And the answer is 20, which was 2% of 1,000. So that is what happens for positive values. If we take a minus 1,000 instead, the answer is minus 140. That's because we had 14% interest rate in this case. So this is how the function is working. We can also use if clauses to protect against errors or unexpected behaviors. So this function compute bank interest takes amount as input, and this number should not be complex. And to check if that happens, we can write an if clause like this. If a mag, which is the imaginary part of a scalar, vector, or matrix, if that one is not equal to 0, well then you have a complex number. And in that case we would like to write out an error message. Error, there is no imaginary money. So error, no imaginary money. And you see that we get a red text here, and we also get an error sound. And usually this is interrupting the running of a function as well. If you more like to have something that is not interrupting and is not written in red, you can use disp for displaying some kind of non-error related message on the screen. And text like this is written just as a text string, but with these apostrophes on the beginning and the end. The next thing I would like to talk about is while loops. And as the name while is saying, this is something that you repeat some computation while a condition is fulfilled. And the condition is checked only at the beginning of each loop. So be sure that the condition will eventually be false, otherwise you will have a loop that runs forever. And the general syntax is that you have while, blank space, and then a condition that you can write in the same way as before. You have some statements or commands that should be repeated, and then when you reach end, you go back to while, and you check the condition again, and then you repeat this over and over again. So here is an example when we are using while loops. Suppose you have borrowed 1 million crowns from the bank. The bank charges 0.25% interest per month, and you amortize 5,000 crowns per month. How many months will it take to repay this loan? Well, that is something that is not so easy to guess by yourself. So let's write a function that takes care of it. I have written a script called predict loan, and the first line is current loan is equal to 1E6. That is a short form for 1 million, because that was the initial loan. Then we define the monthly payment, which is 5,000. We write here that you pay 5,000 crowns each month. The monthly interest was 0.25%, so 0.0025. I have a counter here, month number, and start at 0. And in this way we're going to keep track on the number of months. Then I have a while loop. While current loan is greater than 0, well then you have something to pay back. Then at the beginning of each month you have a current loan, and then you add current loan times monthly interest. and you save it back into current loan. So you are replacing the variable's number with a new number that contains a new interest. And then if current loan is greater than the monthly payment, well, then you are subtracting your monthly payment from current loan and you resave it. So you reduce the loan by the monthly payment. Else, well, that is happening when the current loan is not greater than the monthly payment. Well, then you have less to pay off than the monthly payment. So therefore you put it to 0. And then at the end of the while loop, we take the month number, add 1 to it, and save it again. And then the while loop is going to be running until we reach the point where the current loan becomes 0, and that is when this statement is not true anymore. So let's run it and go to the MATLAB window. We can now see here in the workspace, current loan is 0, so we have paid everything off. Month number is equal to 278. And that's hard to know how many years is that, so let's divide by 12. Well, it takes slightly above 23 years to pay it off. Say that we are changing and we are instead just paying off 1,000 crowns per month, and we run it again. Then what you can see here is that it's still running. In the lower left corner you can say it says busy, and that's because now we are entering a while loop that is going to be running forever, because we are paying off less each month than what interest rate is adding to the loan. In order to interrupt something like that, you press Ctrl C, and then it says operation terminated by the user. And we can now see how many months did it take. Well, 6 billion months to have been simulated here, so things are going on. And the current loan is inf, which means infinity, or rather larger than the largest number that MATLAB can store. Finally, we'll talk about for loops. If you know how many times you're going to repeat the command, it's more compact to use for loops, even if you can use while loops as well. So a general syntax is that you write for and then a name of a variable equal to a vector with values. And here MATLAB is a bit special compared to other programming languages. So the variable will take the values in the vector one after the other. And when it reaches the end, then you are done with your for loop. So you're not saying explicitly how many times you're going to run it, but rather you provide a vector of the length that equals the number of times you're going to run it. And then you have the statements and commands you would like to repeat, and you end with end. The example is like this. Suppose you start saving 500 crowns per month when your kid is born. The monthly interest is 0.17%, which is 2% per year. How much will the kid have at the age of 18? Well, in this example, you know how many months it takes before someone turns 18, so we know how many times you're going to run it. So therefore, we can use a for loop instead of a while loop. Here is predict savings.m that I've created to do these computations. The first line is saying current saving is equal to 0 because the bank account is empty in advance. And this variable, current saving, is going to contain how much money there is on the bank account in the end. We have the monthly saving that is added every month. The monthly interest rate that would also add more money into it. It was 0.17% per month. The number of months that we are going to have is 12 times 18. That's the number of months before someone turns 18. Then we have a for loop, and I have a variable index. That one will take different values between 1 and the number of months. So it will start with 1, then 2, then 3, and so on up until this number that is 12 times 18. Within the for loop, the first row is taking current saving, and then it adds the monthly interest rate. So current saving times monthly interest, and add it. And we resave the current saving. After that, we are taking the current saving and add the monthly saving to it. And we save it again. And then we run it over and over again until we reach in the end of this vector. And at that time we are done. So let's run it and see what happens. Now we can see the workspace contains all the variables. The current saving is something we have here. 1.3 times e plus 0.5. What does this mean? Well, this is 10 to the power of 5, or 100,000, and here we have 1.3 multiplied with that. So it's 130,000 crowns. If we want to, we can change here that we are saving 2,000 per month instead. We rerun it. In this case, we can see that we have instead 500,000. That brings us to the summary. MATLAB is a useful tool for many different types of computations. It could be things that you would do with your pocket calculator, but also things that require some programming, and in particular it's very useful when you would like to have a simple way of plotting nice graphs for your lab reports. It's a standard tool at universities and many companies, and MathWorks is claiming that they have more than 1 million users. Things I would like to tell you is that you should choose your variable names carefully and write comments. That will save you time in the end, because then you can easily go back to your code and see what it was doing and modify it later on. Use scripts and functions. This will also save you time. Try to avoid writing things into the command window. I only do it myself when I would like to try out how a function works, but after that I'm putting everything into scripts and functions. And we have the control statements. If is used to do different things depending on a condition. For loops are used to repeat computation for a predetermined set of values, and while loops to repeat computations until a condition is no longer fulfilled. One of the main goals with this course is to make you self-going when it comes to using MATLAB. So learning how to use the help system to figure things out for yourself and extend your knowledge. So whenever you know the name of a function and you just want to know how it works, then you write help and the name of the function. If you would like to know more, you can write doc and the name of the function and read things and try it out yourself. And this way you will also be able to figure things out later on when you have forgotten some of the syntax. So I would like to wish you good luck with the course, have fun with MATLAB, and learn by exploring how it works and try things yourself.